which is done by what we call miners. And these days, it now depends with the type of chain, right? But if you look at the Bitcoin blockchain, you see that people like they are what are called miners. They are the ones who compute all these values. They add new transactions to the block, and then it goes on and on. But if you go to other chains, they'll start talking about a different type of mechanism. So we have proof of work, we have proof of stake, there's proof of history. You can go ahead and research about all those different types of mechanisms that are used by different blockchains. So the validity conditions for creating a new block. So are transactions valid is the question that every new block or every transaction that needs to be added to the block is in a way, should I say, question. So is this transaction valid? Was it part of the blockchain? Was it, or this is just some counterfeit money that has been created or that has been put into the system? So the validity is very important. And are the digital signatures correct? So whoever signed that that transaction to be sent, are their signatures correct? And then there's a word that you always hear when you're talking about blockchain is called consensus. And consensus is just an agreement that is made by the system when something or a change has happened. So chains with invalid blocks won't be accepted. That is if there is no consensus. But if there is consensus, that means that block is going to be accepted. So a block, you can just think of it as, if we are to do transactions, if I am to send a transaction to person A or to Enoch, and I send another transaction to William, William sends a transaction to someone else, all those transactions, once they are done, they are put in a certain block. So the block just looks like you can just think of it like a box. So we have all these transactions that are going to be written in it. And when it is done, it is closed off. And when it is closed off, it is added to the chain. When it gets added to the chain, that's it. There's no changes that are going to happen on those transactions. Then I have a, so yeah, before we go to the diagrams, also you need to understand cryptographic hash functions. So a hash function, you can just think of it as a function that takes a certain input and gives you a certain output. So whenever you put something into that function, it produces an output. But there is no two different types of stuff that you are going to input into that is going to produce the same hash function. That is where blockchain makes every transaction unique, right? So you can take any byte string as an input, even like a file, right? And then it produces a fixed length output, typically 256 bytes or 512 bytes. Bits are actually, sorry. Then there's different algorithms actually. So examples are the SHA-256, SHA-512, so it depends. But usually you'll see that the Bitcoin blockchain uses SHA-256 for the hash functions. So this is how the structure of the blockchain looks like. So here at the beginning, we have the first block. Okay. It has the index, then the previous hash function, then the payload, which is the contents of that blockchain, and then the hash of that blockchain. So you'll see that on the next block again, you'll see that we have the same hash function that is here this hash function, is going to be used here. This is where it comes into play. So then this block has its own index also, its own payload, and then after that, it creates a hash function. It creates a hash. And that hash is going to be used here where we have previous. And it has its own payload, and it creates its own hash. And it goes like that from one block to the other. Right. So we are using a cryptographic hash function like SHA-256. That means nobody can find two inputs with the same hash value. And that means that record N contains a commitment of record N minus 1. So if this is record N, in record N here, there is this record N minus 1, the previous record. So which contains a commitment also of record N minus 2, which contains a commitment of record N minus 3. So we have the sequence that goes on and on forever and ever. So each and every block contains the hash of the previous block. So this is how these blockchains are going to be intertwined, and all this information is going to be intertwined. So then that makes it really difficult for anyone to try and reverse, or for anyone to try and change the state or change the history of what has happened already, because that means that you need to go into each and every block. If you go into this block and you're trying to change, that means that you have to figure out this hash. And for you to figure out this hash, you need to figure out this hash also. So this becomes very difficult for anyone if you are looking at changing the current state of that blockchain. I hope that is easy to understand. Okay, so let's say an attacker changes the payload or the transactions, should we say, of this block, right? What this means is this is not going to continue like this. Actually, this is what is going to happen. There's going to be the payload for the next one is going to be different. It's not going to be like this. And it will alter everything that happens from there going forward. Okay, so any change in the current state will have an effect on what's going to happen in the rest of the blocks that are going to be formed afterwards. Then hash chains and blockchains. Hash chains have the property that records that every record contains a commitment of all previous records. Like I said, that they are all intertwined. So it's really difficult for somebody to reverse what has happened already. If you change record N, this changes the final hashes of record N plus 1 and N plus 2, and so on. Then the result is once we all accept record N, we have logged in contents of record 1, 2, and 3, N minus 1 as well. Then blockchains use hash chains as a component. Hash chains are also very useful in a lot of other contexts. For example, a system with a trusted arbiter can use a hash chain to limit the arbitrator's power. Even the arbiter can't change the history. So let's say in a system like we were talking about, like a bank, where somebody can have or can alter transactions, we can actually implement a blockchain there so that although they can authorize, they can give power to certain things, they can, I mean, they can yes, authorize certain transactions. They do not have the power to go back in history and change what has happened already. So basically, this is what I just wanted to speak on, to just give an overview of how a blockchain works and how each hash function is dependent on what's going to happen next and also on the previous one. So if there is any questions, I'll stop here so I can give some time to to um, probably talk about a few stuff from the ICP side. So any questions about the introduction to blockchain? Yes, Andrea, you can go ahead.
Hello, nice to meet you. I was just curious what it is written in this presentation, the last row, please. Is it something there that is not visible to me, or I'm not sure?
On this last slide.
Uh, no, the one before, I think.
Oh,
Oh,
this
yeah, so
bottom.
please. Of here it says the hash of the future record. Okay, thank you. that's that's all. Thank you.
Oh, you're welcome.
All right. So maybe we can move on.
Yeah.
Thank you, Mr. Confidence. So that was the intro to blockchain in general. Um, blockchain in general. So I will touch now on the internet computer, the one we will be working with, right? So there's a short video, a short quick introduction video for 7 minutes, which we're going to watch together. And then I'm going to go through a short slide about the internet computer, and then yeah, we'll see where we are at the time, and we discuss a few stuff, and then we can open questions and answers as well. So I'm going to share my screen, and then so we can watch together this short video, an introduction to internet computer. But it's still much harder. Let me know if you can hear the sound of the video. Okay. Web3 is the future, but it's still much harder to use than Web2. The industry is fragmented across many blockchains, forcing Web3 builders to choose between difficult compromises in centralization versus usability. These compromises were only necessary because Web3 was incomplete. In May 2021, this all changed with the launch of the Internet Computer Protocol, or ICP. ICP is a decentralized cloud that bridges the gap between Web2 and Web3. To create ICP, over 100 cryptographers worked for 8 years to perfect an utterly new cryptography innovation. It's called chain key technology. But before we explain how it works, let's quickly look at the incredible things ICP can do. First, let's explore how decentralized applications on. Okay, I see Francis, you're raising your hand.
Yes, I can't see the screen on my AMG, but I can hear the sound.
Okay.
Yeah.
Everyone else can see. Chishimpa, go ahead.
Yes, I can.
Yes, good evening, everyone. Even me, this side, I can't see anything, but I can hear the audio. Now I've seen just ICP, but it is not moving. I can see the sensor.
Is it
Yeah,
playing now?
yeah, okay. Yeah.
So I think it was a network problem.
Okay.
Okay. Thank you.
With Web2 applications, ICP has a powerful new type of smart contract called canisters.
They are decentralized web servers that can directly host full websites with low latency. Canisters can store up to 400 gigabytes of data, perform complex calculations, and connect to Web 2 services and APIs without oracles. Users don't pay gas on ICP. When canisters do computations, they burn a token called cycles from a built-in wallet. This process is called a reverse gas model. Gas costs on ICP usually get paid by the core teams or DAOs that own the canisters, but some dApps collect assets to cover their gas costs themselves. The cycles needed to run canisters can only be minted by burning ICP tokens, and the mint ratio gets stabilized against the real-world costs of running the physical nodes that are doing the computation. The cost of hosting dApps on ICP is consistent and inexpensive, regardless of whether the price of ICP tokens goes up or down. The result is that canisters can deliver decentralized web experiences that look and feel indistinguishable from Web 2. Next, let's look into how ICP connects with the Web 3 world. Most Web 3 blockchains require bridges to connect to other chains. Bridges are built by deploying smart contracts on each chain and relaying transactions between them. Relaying transactions across chains often involves expensive cryptography computation, multi-sig wallets between trusted parties, and off-chain oracles. The complicated architecture of Web3 bridges makes them slow, costly, difficult to use, and prone to security breaches. ICP canisters can directly sign transactions on other blockchains, such as Bitcoin and Ethereum, without bridges or centralized service providers. Canisters can mint ordinals on Bitcoin, deploy smart contracts on Ethereum, and do anything a human user can do across different Web3 blockchains, effectively making them decentralized autonomous Web3 users. The result is that ICP can abstract away the complexity of multi-chain transactions so that users can enjoy a seamless Web3 experience. Chain key technology, the alien tech powering ICP, makes these incredible capabilities possible. To understand chain key, let's review how typical Web3 secret keys work. When a Web3 user wants to create a new blockchain transaction, they sign a message to the blockchain using a secret key that only they know. A threshold signature is when one secret key gets broken up into pieces held by different nodes in a network. Together, these nodes can collectively sign messages without ever revealing the entire secret key to any node in the network. Governments and militaries have been using threshold cryptography to protect their most valuable secrets since the 90s. However, these organizations only execute threshold signatures within controlled private networks. Blockchain networks must be public, trustless, and decentralized. Web3 nodes might be offline or malicious, and an attacker might even try to collect the pieces of the secret key over time. Secure threshold signatures on Web3 were impossible until the Divinity Foundation invented chain key technology. With chain key, up to 1/3 of nodes could be offline or malicious, and the network can still generate a secure signature. The pieces of the secret key stored on each node are also constantly scrambling, so that any information leaked from a node is useless to attackers. This makes it possible to create a decentralized network that can use secret keys no human or computer will ever know. Divinity built ICP on top of chain key technology to completely reimagine what an L1 blockchain could be, with the vision of creating a fully decentralized internet. For example, anyone can verify the content received from the internet computer by simply validating a signature without syncing the entire blockchain. In addition, 0% of ICP nodes run on AWS or other big tech cloud providers. ICP nodes are themselves independent private clouds running in data centers all over the world. Furthermore, nodes on ICP only act as vendors for an on-chain DAO that manages an ICP network, called the Network Nervous System, or NNS. ICP holders who stake tokens in the NNS are the only ones who can control the source code of the network, and they can collectively update the network without hard forks. ICP is entirely alien to anything else within Web 2 or Web 3. which makes it perfect for connecting the two in ways never possible before. With Bitcoin, humanity got the first decentralized network. With Ethereum, humanity got the first decentralized logic. With ICP, humanity now has the first decentralized secret keys, the first decentralized cloud, and the first decentralized AI models. Oh yeah, did we mention that ICP is the only blockchain that can fully host AI models on chain? Now that is alien tech. The future of the internet belongs to everyone, and it won't be harder to use. Whatever blockchains you love, and whatever Web3 future you're fighting for, ICP's alien tech will be a part of it. Explore what ICP has to offer and take your place in the Web3 invasion.
All right. Thank you for watching. That was a brief intro to the internet computer. So just to define a few terms, like I get some people might be totally new to what we are talking about here. Like what is Web3, what is Web2? You were just hearing these terms being thrown around and you don't really understand what it is. So basically, when we say like Web 1, Web 2, Web 3, we are just describing the generations of the web, of the internet, right? Okay, yes, sure. The video will be shared. Thank you. We'll share the video. So when you talk about Web 1, Web 2, we're talking about the generations of the internet, right? Web 1 being like the earliest evolution of the internet, which was like around the 1990s to early 2000, right? Where it was mostly just static content, right? You would just read a website like you're reading a newspaper, per se, like you're just reading content and you can't do anything to it. It was mostly just information and mostly just like HTML and HTML pages on your browser on the internet. You couldn't do nothing to it. So that was Web 1. And then we evolved to Web 2, which is like the most common web we have right now, which is centralized. When we talk about Web 2, we're not talking about dynamic internet, where we're talking about the dynamic web, where like you don't only read information on the internet, but you can actually update content. You can actually interact with the web. We are now talking about the social media platforms like Facebook, Twitter, YouTube. You can interact with them. You can actually create your account. You can actually have your own information there, right? And but the thing with Web 2 now is that they are centralized, right? Like some people control them. Google, for example, Google controls all your data. They can do whatever they want, is what Mr. Confidence was explaining in the introduction to blockchain. Like a blockchain is the main purpose for blockchain in Web3 is to solve this problem of centralization, because we have these big tech companies that are essentially controlling basically our life. Was like our lives are always out there on the internet, on the social media and whatever, and they have full control on them. We don't really have much control. You can get banned anytime. Like you don't have control, right? And they even monetize your data without your knowledge. Like that's how they control. But I don't know if some of you were aware of this recent issue that is going on. Like, what is it? These companies that are scraping content for users on YouTube, like for videos, like scraping the scripts for YouTube content creators, and then like using it for training their LLMs and what's not, right? So it's because they have control, and you really can't do nothing much about it. You can just have to agree, and if it's too much, if you like want to sue them, good luck with that. With suing these multi-billion, trillion companies, right? So this is where Web3 comes in. We are giving power to the people now. We are giving the power, like the control to your data, to your information, to what you own is given back to you. That's Web3. We're talking about decentralization, right? Like you own your own Bitcoin, you own your own ICP, you own your own whatever cryptocurrency you might have. For now, let's just talking about money, right? You are not afraid of anyone, of like receiving an email in the middle of the night, your assets frozen and what's not. If you own your cryptocurrency, you own no one will be able to do anything to it without your permission, right? So that's like the basic idea of Web3. We are saying we are moving away from the centralized services which control our data and basically control our life to an evolution of web where we are the ones in control of our own data, right? So we started with Bitcoin, right? 2008, 2009, and Bitcoin was mostly just about like digital gold, right? Crypto, basically the digital currency, right? And then 2015, we got introduced to Ethereum. Now, Ethereum is not just about money, it's about executing code on the blockchain. We are storing code on the blockchain on Ethereum. We are creating smart contracts. They run some computation on the blockchain, and things do happen. We have a lot of use cases. We have DeFi, SocialFi, we have all those Web3 use cases, which we will dive into in the coming sessions. But blockchain is decentralized, and it's talking of like Ethereum and the most common Web2 smart contracts blockchains. Just a definition, smart contract is this code that is running on your blockchain, on the blockchain, right? So we have these blockchains like Ethereum, Solana, but they are expensive now to like actually build big applications. To like build big applications on the blockchain, they are expensive. Like on Ethereum, it literally costs literal millions of dollars to like store 1 gig or so of data on the blockchain. So this is now where the internet computer comes in. If you have seen in the video, we are saying like a decentralized cloud. So the internet computer is the blockchain, and it allows you to now build applications that are decentralized and that are scalable. Scalability, that's a big issue with blockchains. As I was mentioning, like Ethereum is very expensive, not only it and other blockchains as well. But internet computer now is solving that issue. So scalability, you want to build real enterprise application that can scale to millions of users, and you want all of that to be running on the blockchain with all the blockchain advantages, all right? So this is where the internet computer comes to play. You are now able to store, if you're seeing in a video, like in a canister smart contract, you're able to store like 400 gigs of data, and just in your single canister, and it's and it's easy to create a canister. That's what we'll be diving into in this bootcamp. We'll be teaching you how to create these canisters, right? To build these applications on top of this internet computer platform. So it allows you to build full stack applications. We're not talking about what you find in these blockchains like Ethereum and what's not. They build a smart contract with the smart contract logic, but you find the front end being hosted on a centralized service somewhere, right? And you find since they can't store the data on all the data in the smart contract, some of the information is stored on centralized services like AWS, Google Cloud, Azure, and whatever you name them, right? But now the internet computer is on the internet computer, you can have all of this 100% on chain. So we are now saying on the internet computer you can achieve 100% decentralization. You build applications that are 100% running on chain. You have your back end. You no longer need the Web2 databases like SQL, Postgres, whatever. You don't need those because your canisters can store the state and they are easily scalable, right? Like you can actually have canisters like 1,000 canisters, which are like each holding like 400 gigs of data. It's very easy. You will see what we'll be doing in the coming days, how easy it is to create these canisters. And your front end as well, it can be hosted on the internet computer. So yeah, that's the introduction. And I hope you're excited to actually start building on this alien tech, build applications. So this is the internet computer website, internetcomputer.org. We will send you, right? So this will be one of the good resources to get started on. There's one of my favorite feature is this AI feature. So you basically can ask anything here. Like, I think this will be really useful. Like, you don't really understand exactly what we explain, but something is still not clicking. Come here and ask anything you want, and it will give you a comprehensive response and even give you some documentation. So let's even ask, what is internet computer? Even this basic question, it will help you. So it will generate the response. For you. Exactly. And so you see, very useful. You get to really understand. I'm sure some of you are like completely new to blockchain, completely new to the internet computer. This will be an important tool to play around with, right? And yeah, I think we will dive deeper tomorrow as we will show you guys, because of our time, as we will show you guys how to actually get started and install some tools, and then we can actually write some code. That will be really exciting. Motoko is a very easy and fast language to build with, especially on the internet computer. So these are the languages you can use to build on the internet computer with. We have Motoko, which is the internet computer native language, specifically designed to build internet computer canisters or smart contracts, right? That's Motoko. And we have Rust, We have Rust. Those who know Rust, you can also build smart contracts with Rust. That would be awesome. We have TypeScript and Solidity. We have TypeScript, Solidity. Also, you have Python. We also have Python, and then we have, and then that's like for backend, for creating the backends. You can use Motoko, Rust, TypeScript, Solidity. This TypeScript CDK is still new, still in its beta, but it still works. And then for front end, we have, we kind of highlighted this. Victoria, you can go ahead.
Okay, thank you very much. Good evening, everyone. Sorry, my internet was breaking. I just want to understand about blockchain because in the afternoon when I followed the presenter talked a bit about blockchain. He said it is associated with products, processes, people, and planet. So I just want to understand just a bit. Okay, probably I'll say the definition of blockchain because yeah, when the presenter was saying, I heard some of the things, but I couldn't even relate because I didn't get the actual definition of blockchain. Yes. Thank you.
Okay. Okay, that's good. You watched the first part of the session when you was going through the blockchain, or you were late to this session?
I joined early, but my internet so like it was
Or
breaking. But
so
I learned about the hash, the box thing, that hash payload. Yeah, those things. When he was explaining, I understood. But the problem is that I just don't understand what blockchain. But I heard in the afternoon to say it is associated with products, processes, people, and planet. So I just want a definition to relate or rather put these things together, like products, processes, people, and planet, how they work, or how it is, or how blockchain comes about. Yeah.
okay, it's fine. Mr. Okay, let me just finish this, and then I'll leave this to Mr. Confidence to answer you. Okay, so this will be the languages we have. And then the front-end frameworks, as I was explaining, as I explained briefly in the afternoon, we have React, and then you can use other languages, other frameworks like Svelte, Kit, Vue.js, and even just vanilla JavaScript. So yeah, that's it. Tomorrow we will actually get started and kind of dive deeper into this and get technical. So yeah, there's one question. That question, Mr. Confidence will answer it in a bit, and then others who have questions as well, be ready to ask. So over to you, Mr. Confidence. Maybe disconnected. Okay, that's fine. Let me answer you. So we will. Are you in the Zanzibar Web3 group by any means? Yeah, someone asked for this video. Let me share it just now. Let me share it. Victoria, are you in the Zanzibar Web3 group?
No, sir.
You are not. Okay. Let me share with you. The Msanzi Telegram group. So I'll ask Mr. Confidence to share the slide he was presenting, so you can pick up on some of the things you missed. So blockchain, if you are listening to the bit I was explaining about the Web3, blockchain is the underlying technology to this Web3 evolution of the internet, right? It's decentralized. We're saying we have nodes distributed around the world, right? And these nodes, they're basically not they're basically computer distributed around the node, and then like they hold the history, the state of whatever is happening on that blockchain, right? And with cryptography, right, to make sure they cannot be tampered with. Someone cannot, like a malicious act, a bad actor cannot tamper with the records. Let's say for Bitcoin, for example, like if you want to mess with the records that are in the network, you have to like spoil the whole network. And the way the cryptography works is like it won't allow that to happen, right? So they have this mechanism called consensus, which is the distributed computers, the distributed nodes that are running the blocks which must agree together, right? They must agree, the consensus is coming to an agreement. They must come to an agreement, right? On like on the correct state of the records that are of the blocks on in that blockchain. So, and blockchains are also like immutable, right? Like the internet computer, it's both immutable and mutable, as some of these blockchains are coming, but like by default it will be immutable, so that whatever has been imprinted in the blocks, you cannot alter it. So I think that's the basic technical explanation. We can get to like the, what can I say, maybe the philosophy behind the whole Web3 and blockchain ideology, and kind of get into the business models, why we really need them. That's another topic, and also that's what I kind of explained when I was explaining Web3. Like, we want to give people power back to the people. Like in the blockchain, we no longer have centralized entities controlling our data and our everything. We now have control of what's us, and we don't have big tech just controlling all the important, like parts of our lives, our information and everything like that. So we'll understand more, we will develop. You will really understand as we are developing. We will talk about a lot of interesting stuff in the upcoming sessions. So be sure to join. Our time is really ran out now. 15 minutes, 16 minutes. So anyway, it was really great to meet you guys and start this interesting journey. I hope you really enjoy it and write some code, some Motoko code, and build some interesting projects, and hopefully get to the hackathon and get some grants and actually make real change here, real impactful change with your ideas and your innovations. So I think I'll take a few questions, if there are a few questions, and then we can call it a day. So we'll be meeting tomorrow, same time, 8 p.m. Yeah. Looks like no questions. Okay, thank you guys. Have a good night. Let's meet again tomorrow.
Okay, thanks, Enoch, and good evening. How is it?
I'm doing all right, Mr. William. Really great to see you. Okay.
Yeah. Are you coming to Z?
Yes, we are planning to come. We are planning.
So we'll link up in Mutaka then.
Sure. We'll meet again. Awesome.
Sharp, take care.
Yes, Trust, go ahead.
All right, good evening, everyone.
Good evening.
I just wanted maybe you could clarify like maybe the basic requirements that we need to come with like tomorrow, like our laptops or our gadgets, and maybe some things that we might need to install as we start coding. Thank you very much.
Okay. So, okay, I'll briefly explain this. I think those who are on Windows right now, you need to have WSL installed. So I think that's what you can do for the rest of this evening and tomorrow when you find the time for us to be quick. Try to install Windows subsystem for Linux, WSL. I think sure you can like go on YouTube, right? And like there's a ton of videos and guides on how to install WSL. That will make it easy to install the tools we will need to develop on the internet computer. So if you're on Windows, yeah, try to do that by tomorrow, and then we can take it from there. So yeah, that's really it. Like at least your laptop and then internet, kind of stable internet. That's basically it. And then we'll be starting from the basics. So yeah, WSL in preparation, and then bring your laptop and yeah, and try to ensure you have somewhat stable internet. Okay, so yeah, that's it. Thank you, guys.
So what of those using Linux?
Those using Linux, they don't have to worry. Like, okay, let me just send this documentation. Those both on Linux and like on Mac OS, you don't require extra tools to install for you to be able to Yes, I'll send this link. This is the documentation to the Internet Computer website. So you can actually go ahead and install the Internet Computer CDK yourself. It's all on that documentation I just sent in the chat. So if you're on Windows and you install WSL, go ahead and open that link and install the required tools. And if you're on Linux, just use that one. Yes, Chishimba, go ahead.
Okay, thank you very much. I just wanted to find out, is this only for those who are doing computer science, or even us who are doing business administration? How can we benefit from this? Because
Okay.
some of the terms that you are using, they are all new to me, I think. They are all new to me. How can I benefit from this? Yeah.
Okay, so I get you. Like, so anyone can join. But as you can see, this bootcamp is actually technical because we will actually be writing actual code. You see, actually developing code. So even from business side, there will be a bit of a learning curve, as you are saying. Like, some of the terms are new, but like we will try to, like, on the basics, to make even the newbies to really understand. But yeah, it goes without saying, like, if you are completely new to the ICT and like you haven't really coded anything, yeah, there will be a bit of a learning curve. As you're saying, most of the stuff will be new to you. So yeah, it will be easier for people who are already predisposed to this, to like coding, like computer science people. But yeah, anyone will be able to do it, but it will just be, there will just be that learning curve for you. So I think, but like, just try to find maybe a team member or someone, like, if you feel like you have some interesting ideas you would like to get through, try to find a peer who is like, who likes know how to code, or who is familiar with coding or computer science, who you can like work with throughout this bootcamp and also even into the hackathon. But we will try our best to support you as well, even if you're completely new. So be sure to join our Telegram channel and feel free to reach out to us through the channel or even directly in our DMs, and we will try our best to assist you. Okay, that's awesome. Okay, thank you guys. Good night. Let's meet tomorrow.